This is a function y equals x squared plus 2x cubed minus 1. Is it? So it's x cubed plus 2x squared minus 1. X cubed plus 2x squared minus 1. I should have here. So what I have is x cubed plus 2x squared minus 1. Now, we want to find the critical points. So we find the first derivative, dy by dx, first derivative of y with respect to x, dy by dx is equal to 3x squared plus 2 2's 4x. That's it. And then we know that at the critical points, whether they're maximum or minimum, they're equal to 0. Now, if we factorize and put x outside the bracket, we have 3x plus 4 equals 0. So that means x equals 0 and 3x plus 4 equals 0. If 3x plus 4 equals 0, then x is equal to negative 4/3, which is negative 1 and 1/3. Alright, I have the graph plotted here with GeoGebra. So negative 1 and 1/3 and 0. Now, I can see that the value at negative 1 and 1/3 is a stationary, or is a maximum critical point. The 1 at 0 is a minimum point. But if I did not have the graph and I need to sketch this function, I would have to find the second derivative, d square y by dx squared. So I differentiate again. This is what I would have to differentiate again. So I have 326 x plus 4. 6x plus 4. Right? Now, here, if I substitute x is equal to negative 4 over 3 in it, then I would get 6. Oh, let's substitute x equals 0 first. 0 would be on the left. If I substitute x equals 0, then 6 times 0 plus 4 is equal to 4. 4 is a positive number. So the fact that you have a positive value means that we have a minimum point. Alright? So we have a minimum point. Positive value, because if you are here at that minimum point, it's like you're in a valley, and any direction you turn, once you start walking, you're climbing uphill, so you're going up. So the value there would be a positive. Now, if you substitute x is equal to negative 4/3, what you're going to get is that d squared y by dx squared is equal to 6 times negative 4/3 plus 4. Now, this will be 3 into 3, 1, 3 into 6, 2. 2 by negative 4 is negative 8 plus 4 is equal to negative 4. This is a negative number. Once it's a negative number, we are at a maximum point. Now, we're at the maximum point. any direction you move, you're going to be going downhill. So once you're going down, you are at a maximum point. The second derivative is a negative. Now, the second derivative, 6x plus 4. Suppose we equate it to 0. 6x plus 4 is equal to 0. Then you would have 6x is equal to negative 4. X would be negative 4 over 6, which is negative 2/3. Now let's look at this. Negative 2/3 is negative 0.66. If we look at this graph, we see what we have is the location of the point of inflection. When we equate the second derivative to 0 and solve, what we have is a point of inflection, right? Now, what we would have at that point, let me see if I can find a tangent line somewhere here. No, this is my tangent line. Let's make the tangent line a bit thicker. And I'll make it a blue line. As I move, you'll see at the maximum point the gradient goes from positive towards negative. As I move to the right, the gradient is becoming more and more negative. But when the tangent is slowing down, when the tangent reaches a point of inflection, it switches from going more negative, it stops and starts going positive. Where it stops and changes direction is a point of inflection, and then it swings upwards. We see that at the minimum point, right at the minimum point, we have a gradient of 0. It's becoming more and more positive, it reaches 0, and then once you pass the minimum point, it's becoming more and more positive. Alright? So, those are minimum point, maximum point, and the point of inflection.